All right, we're going to look at example 12.5. Okay, 12.5 states that a particle moves along a horizontal path with a velocity of this, v. What do you notice? V is a function of time, where t is in seconds. If it initially located at the origin, determine the distance traveled in 3.5 seconds, and the particle's average velocity, and average speed during that time interval. All right? So, written it down here. This is v as a function of time. Okay? So, let's look at A. Determine the distance traveled in 3.5 seconds. Now, what is distance related to? So, let's just look at, let's call this question 1, question 2. Question 1, distance is related to position, right? Remember that if we have a straight line, particle is there, it moves there, it comes back, so it starts there and it comes back to there, right? The distance is related to the position. So the distance is just the total length that you've traveled, okay? So in order for us to solve this problem, distance traveled, we've got velocity as a function of time. We want distance, which means what we should try to find first is our position as a function of time. Okay, we'll see that. So again, we've got v as a function of time. We've got v, t, and we want s. So we can make use of this equation, v equals ds dt. All right. And v is a function of time, so we separate variables. We are going to get 3t squared minus 6t dt, and we're going to integrate that. Because why? We want s as a function of time. And that is the integral between 0 and s, between 0 and t. And we rearrange this, we're going to get s is t cubed minus 3t squared. Okay, meters. Okay, so we are after distance traveled, but this is a position function, a position time function. All this tells us, guys, is at t equals 1 second, what is my position at that time? At t equals 100 seconds, what is my position? It doesn't give us the entire distance information, it just gives us our position. So let's have a look here quickly at something. Let us try to draw this curve, S, T, okay? I'm just going to do this quickly. So let's look at time 0, 1, 2, 3, and 3.5 seconds. Let's have a look at our position at these times. At t equals 0, our S is 0. At t equals 1, our position is minus 2. At t equals 2, our position is minus 4. At t equals 3, our position is 0. At t equals 3.5, our position is 6,125. So if we draw this, there's our position time curve. At 0, our position is 0. So let's just do this, 1 second, 2 seconds, 3 seconds, and then 3.5. So at 0, we're at 0. At 1 second, what's our position? Minus 2. Okay? And at 2 seconds, what's our position? Minus 4. And what happens at 3 seconds? Suddenly, we're back at the origin. And then at 3.5 seconds, we're at 6,125 meters. So we've done something like this, okay? It looks something like this, okay? But we don't know if that is our turning point. Okay, I've drawn it like that, but we don't know if that is our turning point. Let's have a look at it in terms of a straight line. Say that's our origin. We started at the origin. Okay, that's 0. Then we move to minus 2. Then we move to minus 4. And then suddenly at 3 seconds, so that's time equals 0, 1 second, 2 seconds, then suddenly at 3 seconds we're back. This is t equals 3. We're back at 0. Okay, and then at 3.5, we are all the way here at 6,125. Okay, that's t equals 3.5. So the reason I'm doing this is because we are trying to find the distance traveled. Okay, we're trying to find our distance traveled. So what I'm doing is I'm plotting it out so that I can see how this particle moves over time. Because we're not looking for displacement, we're looking for distance traveled. Distance traveled is the total path that it moves. Okay, but the problem we have with plotting s and t, s as a function of t, is we are not 100% sure where we turn. Okay, it could be that between 2 seconds and 3 seconds it still goes on a bit and then it turns around. Okay, but we're not sure. We're not sure if this at minus 4 meters is our turning point. Okay, so what do? We consider velocity equal to 0. Why is that? Because at that turning point where the particle turns around to start going in the other direction, we have velocity equal to 0. At any turning point, our velocity is equal to 0. So if we take this equation, that equation, and we solve for, we set it equal to 0 and we solve for time, we say 3t squared minus 6t equals 0, and we solve for time, we're going to get t equals 0 and t equals 2 seconds. So that means that at t equals 0 and t equals 2 seconds, t equals 0, t equals 2 seconds, we have velocity equal to 0, which is at the beginning, and velocity is equal to 0 at minus 4 meters. So we know that velocity is 0 at s equals minus 4. So that means that point there is indeed a turning point. It is indeed a turning point. So the reason why that's important is because we're trying to measure the total distance. And if we don't know where it turns, we can't measure how long this distance is. So our total distance then would be this length, and now we know it turns around at minus 4, plus that length, plus that length. So it's going to be 4, that's 4 there, plus 4, plus 6,125. And that equals 14.125 meters. That is my distance traveled. Please make sure you know how to do this. Please make sure you understand. We're trying to find our distance, so we need our position time function. Okay? Our position time function allows us to plot something like this, which is good. It's exceedingly helpful, but we need to determine where is our turning point. Our turning point is determined by setting v equal to 0 and solving for the time when it is 0. So we know that v equals 0 at t equals 2 seconds, which is at minus 4 meters. So we know our turning point is there, and we can add up our distance traveled. Okay, so that's question 1 done. Question 2 is simple. V average is delta, is your displacement over delta time, over your change in time. What is my displacement? My displacement is my S final minus S initial over change in time, which is, what is my final position? 6.125, measured relative to this, right? It's 6.125. What's my initial? 0. And my change in time is 3.5. That should give me 1.75 meters per second. What is my average speed? It is my total distance traveled over time, which is 14,125 over 3.5, which is 4.04 meters per second. All right, so please go over this on your own. Make sure that you understand how to do this problem. Okay? Thanks, guys. Cheers.